Homework 5.1, System of Equations, Video 7. Homework due Friday, May 29th at 11:59 p.m. In this very last video for this homework series, for Test 4, and for the entire course, we're going to look at solving a 3x3 system. Now, I mentioned before that I know multiple ways to solve systems of equations. For this one, we're just going to solve it by addition. Substitution would work, but you would have to do it multiple times, and we're going to have to do addition multiple times. This is the one. This is the technique that I can describe most cleanly, how to solve a 3x3 system by addition. Let me kind of tell you the general plan of attack. When we solved the 2x2 system, our move was geared to shrink it down to a 1x1 system, which we could solve. So from two equations with two variables to one equation with one variable. Our strategy for a 3x3 system is to shrink it down to a 2x2 system, at which point we shrink it down to a 1x1 system and then solve it. So that's going to be our approach. Shrink this down to a 2x2 and then shrink it down to a 1x1. And honestly, the technique I'm about to show you would also work for larger systems. How can you solve a 4x4, shrink it to a 3x3, and then a 2x2, and then finally a 1x1 system? So how do we shrink a 3x3 to a 2x2? Well, a 2x2 system has two equations with two variables. So we need to manufacture two equations with only two variables. And we have three equations with which to do it. So, move number one. Pick two equations, comma, and eliminate one variable. So we have some decisions to make. Now, because we're going to have so many equations floating around, I'm going to number these equations 1, 2, and 3, and there will be more equations soon. So we have a decision, we have two decisions or three decisions to make. Pick one equation, pick another equation, pick a variable to get rid of. Now, we can use the same approach before by choosing a variable and then reversing its coefficients as multipliers. So really, it doesn't matter what letter we pick or what pair of equations we pick. So, just for the sake of simplicity, let's pick 1, 2, and let's eliminate z. So let's think about how we're going to set this up. Let me start by writing equation 1. 5x plus 4y minus 5z equals negative 56. And equation 2, 3x minus 5y plus 3z equals 20. And let's focus on eliminating the z's. Since the coefficients are 5 and 3, let's reverse them. Our multipliers will be 3 and 5. Remember to multiply both sides. Do we need to change a sign? In this case, no. 3 times negative 5 is negative 15, but 5 times 3 is positive 15. So this choice of multipliers will get us what we want, opposite z's. If I triple the top equation, I'll get 15x plus 12y minus 15z, and I haven't had the chance to tell you guys this, but when I write my z's, I put a line through them so you know that they're not the number 2. There are some classes where z shows up a lot. This just wasn't one of them. Equals. Negative 56 times 5 is negative 280. Use a calculator if you want to. If I multiply the bottom equation by 5, I will get 15x, those are almost opposites, minus 25y, plus 15z, there's the opposites I built, equals 100. And now if I combine these equations, I'll get 30x minus 13y, the z's cancel, and this equals negative 180. I'm going to call this equation 4. Remember, we're trying to build a 2x2 system, so we need two equations with two variables, and there's one of them. But now, we need another equation with the same two variables. So we need another equation with x and y. So for the second step, pick a different pair of equations, pick a different equations. Doesn't matter which two, just as long as it's not the same pair. But eliminate the same variable. So we need to pick a different pair, but also get rid of z. Why don't we just pick 1 and 3? Does it really matter? You could have picked 2 and 3. Pick 1 and 3, and let's get rid of z. So let me write equations 1 and 3. Equation 1 is 5x plus 4y minus 5z equals negative 56. Equation 3 is 6x minus 4y. Well, those y's are ready to go, but I'm getting rid of z's. Make a plan and stick to it. 6x minus 4y plus 6z equals 16. We're still concentrating on getting rid of the z's. And so we need to choose our multipliers. Since the coefficients are 5 and 6, we're going to multiply by 6 and 5. They are already opposite signed, so I don't have to adjust that. And that will give us, on the top, if I multiply by 6, 30x plus 24y minus 30z equals negative 336. Let me make sure. Yeah. And the second equation, if I multiply it by 5, will give us 30x minus 20y plus 30z, there's my opposites, equals 80. And now if I add these equations together, I get 60x plus 4y, the z's cancel, equals negative 256, I believe. Let me add to make sure. Yes. We'll call that equation number 5. Now, some of you may recognize that this equation, all the numbers are reducible by 4. I can divide everything by 4. Since that won't always be an option, let's just run with it as is. At this point, you have 2 equations with 2 variables. So now, your third step, it's going to be short. Solve the new 2 by 2 system. The new 2 by 2 system. The instructions are short, the execution of it maybe not so. So now we have a new 2 by 2 system, equations 4 and 5. Equation 4 was 30x minus 13y equals negative 180. Equation 5 is 60x plus 4y equals negative 256. And now we just solved the 2 by 2. And, well, there's a fourth step. I bet you can figure out what it is. Let's solve this by addition, but let's be a little more observant and frugal with our multipliers. Look at the x's. One's a 30, one's a 60. I can make them match pretty easy. I can multiply the top equation by 2. Now, you can still use the reverse the coefficients and multiply and get really large numbers to deal with, but sometimes there's something nicer to use. But wait a minute, 2 won't work because that will make both of them 60. I need to multiply the top equation by negative 2 if I'm going to set up the x's. So let's multiply the top equation by negative 2. See what that gives us. If I multiply the top equation by negative 2, I get negative 60x plus 26x equals 360. Yeah. If I leave the bottom equation alone, I get 60x plus 4y equals negative 256. This is worrying me. I'm going to make a mistake somewhere. I get 30 y's, the x's cancel, I get 30 y's, but over here I get 104. And the thing that I'm worried about is that I was 99% confident that this was going to come out to be a whole number. I really don't want to restart the problem over again, so I'm going to retrace my steps. I know this video has already kind of gone a little longer than I wanted it to. What are we at? We're at 10 minutes right now. But as I've said before, there's nothing wrong with making mistakes. The problem is when you make them and don't learn from them. But like I said, I am 99% confident that when I picked these problems for the homework, this one, that the answer came out to be whole numbers, and it's about to not. Now some of you may be saying, I see where your mistake is, but I can't hear you. So I'm just going to retrace all my steps, make sure I wrote everything correctly. 5, 4, negative 5, negative 56, 3, negative 5, 320, 6, negative 4, 6, 16. So this is good. Did I copy the first two equations correctly? 5, 4, negative 5, negative 56, 3, negative 5, 320. That's correct. Did I set up the multipliers correctly to eliminate the z's? 3 and 5. I found a mistake. Did you? You probably saw it a long time ago and you were yelling at me and probably thinking, why can't I? Because this isn't live. It's live now, but when you're watching it, it's not. This wasn't supposed to be a 5. Que lástima. No hablo español, but I can speak enough to make you think I can. I was supposed to multiply this by 3. 3 here, 3 there. So let's do some what I call damage control. Let's see the ripple effect of changing this 5 to a 3. This should have been negative 56 times 3, which is negative 168. 115, 18, yes. So this should have been negative 168. You know what, I'm going to keep track of my changes in red, just so I can look back and say, look at all the mistakes that happened. Well, actually, I think I made one mistake and it just caused a huge ripple effect. This is why you send me pictures of your work on your test. Because if you make one mistake and do everything else correct, you should get a lot of points for the work, even though your answer is completely wrong. Times 3 gives us negative 168. So when we add these, we get negative 68. That was equation 4. So negative 68 goes here. And we multiply that by negative 2. So 120 and 16 is 136. So this should have been positive 136. And when we subtract these, we get negative 120. For a couple of reasons. Caught the mistake, damage control was fairly minor, and most importantly, this will be an integer. Y is negative 4. But be careful, we're not even done with step 3. Step 3 to solve the new 2x2 system. To solve this means knowing x and y. So now I have to take this y, put it back over here somewhere and solve for x. I think I'm going to put it into the top equation just because it wasn't botched up. So if I put negative 4 back into this equation for the y, I get 60x plus 4 times negative 4 equals negative 256. 4 times negative 4 is negative 16, so I get 60x minus 16 equals negative 256. If I add 16 to both sides, I get 60x equals negative 240. And if I divide both sides by 60, I get x equals negative 4. So x and y are both negative 4. That'd be crazy if z was also negative 4. By the way, fourth step and final step, after you've solved the 2x2 system, you'll know 2 of the 3 variables. I'm just going to say figure out the last value. Figure out the last value. If you want more specific, take the solution to the 2x2 system, substitute it into one of the original 3, and figure out the missing variable. So, we need to take negative 4 for y, negative 4 for x, plug it up here somewhere, and figure out z. Let's just use the original first equation. Alright, so x is negative 4, y is negative 4, z we don't know. 5 times negative 4 is negative 20. 4 times negative 4 is negative 16. Look at all these negatives. Negative 20 and negative 16 is negative 36. Minus 5z equals negative 56. Add 36 to both sides. We get negative 5z equals negative 20. And divide both sides by negative 5. And we get z equals 4. I know it's messy in there, but it's a small board and it's a big problem. So as an ordered triple, which is a point in space, an ordered pair is a point on a plane, x is -4, y is -4, z is +4, the problem's done, the video's done, the homework's done, the material for test 4 is done, the class is done, I am done. Actually, I'm not done because I have to wait for you guys to take test 4, send me your scratch work so that I can award partial credit. This has been quite the journey. I have taught Maymester College Algebra many, many times before. I have never taught it as an internet class. I hope these videos have helped you. I know a lot of students get help using View and Example. Why am I standing back here? This is my swan song. I should be right here front and center. I hope these videos have helped you. I know a lot of students just get online, click View and Example, and work their way through answers. But if you learned anything from these videos, if you have any feedback, any commentary, please shoot me a message in Canvas, or please send me a text, because after the class you may not be able to get in Canvas. Let me know what was good, let me know what could use some improving. I don't normally teach internet classes, but because the whole world is coming crashing down right now, that was the only option for Maymester. So I've enjoyed these, and for anybody else who's not in my class who happens to be watching these videos, because I get the feeling that there will be more people checking these out simply because the entire college algebra course is in these videos. There's a few things I skipped, but nobody's perfect. So just let me know if you liked them, and if there's something I can do to make them better in the future, I will work on that. Thank you, and have a good day.